Number 71. This is a very delicious problem where you need to really understand the free body diagram. So we have a suitcase on a carousel, and it might seem like this is very similar to a banked NASCAR problem, but the thing is, NASCAR, in NASCAR, cars are riding on the road and they're pushing into the surface. And that's when you have normal force creating your centripetal force. This is riding on the outside of the slope, not into the slope. And normal force is actually going to be subtracting from your centripetal force. So here's the free body diagram, just like on any kind of incline. So this is what they're telling us. It's at 20 degrees and there are two different radii. So normal force, as on any other incline before NASCAR problems that we'll look at, it would be equal to the gravity y. Then think about what two, not just one, but two forces that contribute to your centripetal force. So the centripetal axis is right here. Right here. So you see that gravity itself has absolutely no, let me make it dotted so it's not, and kind of, there we go. So gravity has absolutely no effect on your centripetal force. It does not contribute in that direction. So you will have normal force, this right here, oops, this right here. What is going on? Let's do maybe red. So this part that comes as an f and x, I'm going to call that f and, or let's say radial. So that is the radial component of normal force that is pushing to the left. So it is actually the so-called centrifugal force because it's away from the center. And then this part right here, which is force of friction radial. That one is pointing to the right. So ultimately, what you have here is centripetal force is force of friction radial minus force of normal radial. Now how do we find those? You need to realize that if this right here is 20 degrees, then that sucker is 20 degrees. And then your friction radial is going to be force of friction times cosine of 20 degrees. And force of normal radial, that would be your 20 degrees. And then your force of normal radial is going to be sine of 20. Or you can do cosine of 70, it's up to you. I prefer sine of 20. So force normal times sine of 20. But then what is force normal? Force normal is itself, not force normal sine, but force normal itself is mg cosine of 20 degrees. Lots of sines and cosines, so we're gonna calculate them to make it easier so we don't have to drag the cosine and sine. And if we round, we are bound to get slightly different answers that the book gives us, and that is because in the book they actually go the full way, sines and cosines of 20, and they don't round, and then in the end they're like a tenth or 100th off. We're not going to do that. So first off, they give us this distance right here to be 746 meters. 746 meters. Then radius of rotation right here. Radius is going to be 746. And what do you know? Cosine of 20. Cosine of 20 degrees, and if you put that into your calc, you will get about 7.0 meter. My first rounding here, it's 7.0 with a tail, whatever. So if this right here is our radius, and we also know that in the first part of the problem, our rotation takes place over 38 seconds, then I can figure out my speed, or not my speed, but the suitcase's speed, is going to be 2 times pi times 7 over 38. V amounts to 1.16 meters per second. So this is how fast, that's the tangential speed, how fast our suitcase is going around that carousel. 1.16 meters every second. So then, if I know my V, I know my mass, and I know my radius, why don't I go ahead and calculate what that centripetal force equals? So the formula for centripetal force is mv squared over r, where m is 30 kilograms, v squared is 116 squared, and then r is 7. So that amounts to about 5.77 newtons. Then centripetal force, remember centripetal force from right here is the difference between the two radial components, the radial of friction and the radial of normal. Normal I haven't found yet, but I know that normal is going to be mg cosine of 20 degrees. And then I need to multiply that by sine of 20 degrees to get my radial component. Correct? Correct. So I end up with force normal radial mg cosine of 20 times, oh, not squared, sorry, mg cosine of 20 times sine of 20, so it's the same as mg over 2 times cosine of 40. Oops. Wait a second. I mean sine of 40. Because it's the sine of a double angle is 2 times sine times cosine of half the angle. So there will be sine of 40. And when I plug that into my calculator, I end up with 30 times 9.8 times sine of 40 degrees. That's 188. Oh, forgot to divide by 2. Divided by 2, 94.5. And that is going to be newtons. 94.5 newtons. So that is my F and R. Then, centripetal force being 5.77 equals force friction cos of 20 minus 94.5. Then from there, force of friction would be 94.5 plus 577 over cos of 20. And real quick, 94.5 plus 577 divided by cosine of 20. 106.7, so 107. 107 Newton. In the book, they actually come up with 106. Oh, well. That's because I rounded a little bit before. Anyway. Now, the second part about this problem is when they start rotating the carousel faster, the suitcase slides down. They've worded as gets bumped to a different radius that is a different distance technically. The distance now becomes 7.94, and the funny part is if you find the new radius, so if distance is 794 meters, then radius is now 746 meters, kind of like what it was before. This was 746 was the distance before. Anyway, so that's your new radius. Then with the new radius, your new speed is going to be 746 times 2 pi. And the new time, they are now rotating at 34 seconds. 34. So that gives us 1.38 meters per second. So that's our new speed. From our new speed, we get our new centripetal force being 30 times 138 squared over the new radius of 746. So back to figuring out centripetal force is going to be, again, mv squared over r with the new v and the new r amounts to 766 newtons. Then, after we figured out our centripetal force, we're going to figure out our friction force. Force of friction is going to be the new, so our, what was our normal radial didn't change, 94.5 still. Our new centripetal is 766 over cos of 20. That gives us, so 94.5 plus 766 divided by cos of 20 gets me 108.7 newtons. That's force of friction. And as you know, static friction coefficient would be force of friction over force normal. So that's going to be 108 divided by our mg cos. So, sorry, 108.7. So 108.7 over 39.8 cos of 20. And that gets me 3.395. That is, that is the coefficient of static friction. And that is the beautiful, mathematically tedious, but from the physics point of view, so beautiful with all those forces you have to figure out. Problem number 71.